When you hear the term fiber-reinforced composites, you may ask, what exactly are composites? Let's explain. A composite is a term that represents the combination of two or more different materials. But do you know what are the benefits of composite materials? It is simple. In composites, different materials work together, giving the composite overall greater properties than each material alone. Because of this, composites have become one of the most promising materials in this century and have found various applications in different fields. Fiber-reinforced composites are made from fibers and matrix, as shown in the figure. But do you know the role of fibers in FRCs? Their main job is to provide strength and stiffness to the composite. And what about the matrix? The matrix, usually made of resin, holds the fibers together. When the matrix and fibers work together, FRCs exhibit excellent mechanical properties. This makes them suitable for various applications due to their interesting features. But do you know what makes the mechanical properties of FRCs so exciting and gives them advantages over traditional materials? Let's find out. Fiber-reinforced composites have several remarkable features that set them apart from traditional materials. Firstly, they possess high strength and a valuable elastic modulus, indicating their stiffness. This makes them stronger compared to many other materials. Additionally, they exhibit considerable durability, meaning they remain functional without requiring frequent maintenance or repair. This durability is valuable as it helps materials last longer with fewer repair costs. FRCs are lightweight yet possess higher strength to weight ratios than existing materials. This makes them easier to be used in various applications without the limitations due to excessive weight. Another notable advantage is their resistance to corrosion, impact, and fire. These characteristics has made them suitable for manufacturing firefighting clothing today. These advantages have attracted the attention of practitioners in recent years, leading them to prefer using FRCs over other materials. Firefighting clothing is just one of the many applications of these materials. Let's see some others. Fiber-reinforced composites have also been widely used in the production of airplane parts in the aerospace industry. Many parts of Airbus planes and other aircraft are made from these materials, as seen in the picture. FRCs help reduce the weight of airplanes and their fuel consumption. They also enhance aircraft aerodynamics and improve their ability to withstand fatigue and corrosion damage. FRCs can be utilized in defense systems, such as enhancing the mobility and protection of military vehicles and helicopters. They also help reduce radar and thermal detections. In the image, you can see a composite-made vehicle. Moreover, today numerous parts of helicopter rotor blades are constructed using composites, thereby improving their performance. Fiber-reinforced composites, or FRCs, have various uses in the automotive industry to make cars safe and more efficient, while also decreasing emissions and noise. You might wonder where they are used. Just take a look at the picture. As shown, many parts in big companies like BMW or Mercedes-Benz are made with fiber-reinforced composites. Now you can better understand how FRCs are utilized in the automotive industry. Have you ever thought about using FRCs in the construction industry? These materials promise to enhance the durability and lifespan of structures while also lowering maintenance and repair costs. In the images, you can see examples of how fiber-reinforced composites are used in construction complex architectural structures and bridges. FRCs can also be used in the marine industry to make boats and ships perform better and stay stable. They also help protect submarines against corrosion from sea water. Here you can observe the manufacturing process of a boat using FRCs. Today, FRCs have found extensive use in the medicine and biomedicine fields for creating dental bridges and implants that replace one or more teeth. They have become practical for use due to their ability to provide strength and stiffness similar to that of natural teeth. In addition, they are widely employed for orthopedic implants. This video displays a fracture fixation device composed of a multi-layer metal-free fiber reinforced composites. Made of carbon fibers, it provides the necessary stiffness and strength to withstand high loads. It is thinner than traditional metal plates and fits well with the bone shape. Additionally, it is radiolucent and allows clear bone imaging, unlike metal plates. These are a few applications of FRCs among others.